Welcome to our deep dives today, and we are going to be talking all about flight control systems.
Oh, yeah.
And to help me do that, we have our expert here.
Hello.
Today's source material is excerpts from a pilot training handbook.
Cool.
And we're going to go through and just kind of talk about how planes work and how those systems have evolved over time.
Sounds good.
So, I guess just to get started, like when you think about just like controlling an airplane, like what are like the very basics? Like how do you move that thing through the air?
So the basics of flight control come down to controlling the aircraft's movements about three axes.
Okay.
So you have roll, pitch, and yaw.
Okay.
So imagine holding a model airplane.
Okay.
If you tilt it side to side,
Yep.
that's roll. If you point the nose up or down, that's pitch.
Okay.
And if you swing the nose left or right, that's yaw.
Gotcha.
And by controlling these three movements, you can essentially steer the plane and maneuver it through the air.
Okay, so like how does a pilot actually make those things happen? Like what are the actual physical things that they do?
So to make these movements happen, we have control surfaces.
Okay.
Think of them like the movable parts of the wings and tail
Okay.
that allow the pilot to control the plane's movements.
Gotcha.
Yeah.
So like what are some examples of those control surfaces?
So we have ailerons,
Okay.
elevators, and the rudder.
Okay.
These are the primary flight controls.
So like how do the ailerons work?
So the ailerons are located on the trailing edge of the wings.
Uh-huh.
When the pilot moves the control stick left or right, the ailerons move in opposite directions.
Okay.
This creates a difference in lift between the wings, causing the aircraft to roll.
Okay, so if I move the stick to the left,
Yeah.
the aileron on the left wing goes up
Goes up.
and the aileron on the right wing goes down.
Exactly.
So it's
And
now-
that causes the plane to kind of bank to the left.
Okay, gotcha. And what about the elevator?
So the elevator is usually located on the horizontal stabilizer at the tail. Moving the control stick forward or back controls the elevator, making the aircraft pitch up or down.
Okay, so forward is down.
Forward is down.
Okay, cool.
Back is up.
Gotcha. Okay, so and then the rudder.
The rudder is a vertical surface on the tail. It controls yaw.
Okay.
So using rudder pedals, the pilot can swing the aircraft's nose left or right.
Okay. So we've got these three main control surfaces: the ailerons, the elevator, and the rudder.
Yeah.
Each one is responsible for moving the plane on a different axis:
Exactly.
roll, pitch, and yaw.
Yeah.
That's pretty cool. So like back in the early days of aviation, like how did all this stuff actually like connect? Like was it just like strings and pulleys?
It was surprisingly simple.
Oh.
Early aircraft used a system of cables, pulleys, and rods to connect the pilot's controls to the control surfaces.
Okay.
Yeah.
So like pretty low tech.
Low tech, but very effective.
Okay.
And, these systems are still used in some smaller aircraft today
Okay.
where the forces aren't as strong.
Gotcha. So it works for like the small planes where the pilot doesn't need like a ton of assistance
Exactly.
to actually move the control surfaces.
Yeah.
Okay. But I'm guessing as planes got bigger and faster that like those cables and pulleys like weren't really cutting it anymore.
Yeah, you're right. As aircraft grew larger and faster, the forces on the controls became too much for a pilot to handle alone.
Yeah. So, I mean, like, what did they do? Like, did pilots start like lifting weights or like how did they solve this?
No, they came up with a better solution.
Okay.
They introduced hydraulic systems.
Okay.
These systems use fluid pressure to assist the pilot in moving the controls.
Okay. So it's like power steering for airplanes.
Exactly, like power steering for airplanes.
Gotcha. That makes sense. So basically, like instead of like the pilot's muscles doing all the work,
Yeah,
it's this hydraulic system that's helping them out.
exactly.
Okay.
It made the planes much easier to control.
Okay, cool. And then I guess like eventually that led to fly-by-wire.
Yeah. Eventually, we saw the introduction of fly-by-wire systems.
So like explain what fly-by-wire is. Like what does that even mean?
So with fly-by-wire, the physical connection between the pilot's controls and the control surfaces is replaced with electrical signals.
Oh, wow.
So basically, when you move the stick or press a pedal, it sends an electrical signal to a computer,
Okay.
and the computer then controls the actuators that move the control surfaces.
Okay, so the pilot's basically like playing a video game.
In a way, yes.
Okay, so there's no like direct connection between what they're doing
Yeah,
and
no direct connection.
what's happening with the control surfaces.
Exactly.
Okay, that's really interesting. So like what are some of the advantages of going to a fly-by-wire system?
There are quite a few advantages.
Oh.
First, it makes the aircraft lighter
Okay.
because you no longer need all those heavy cables and pulleys.
Yeah. That makes sense.
And that means better fuel efficiency.
Okay.
And then another big advantage is it allows for more sophisticated safety features.
Like what kinds?
Well, for example, you can have systems that automatically compensate for things like wind gusts or turbulence
Oh.
to keep the plane flying smoothly.
So it's like having a little bit of autopilot built in, even when you're flying manually.
Yeah, you could say that.
That's pretty cool.
Yeah.
And I know our source also mentioned something about NASA researching intelligent flight control systems.
Yes, those are really interesting.
What are those all about?
So these systems are designed to be even smarter than traditional fly-by-wire.
Oh,
They
good.
could actually adapt to damage or failures.
Oh, wow.
So let's say an aircraft loses a control surface due to damage.
Okay.
An intelligent flight control system can detect that and reconfigure itself to still allow the pilot to control the plane.
Oh, wow. So it can like work around problems and keep the plane flying.
Exactly.
That's incredible.
It's pretty amazing technology.
Yeah, that sounds like something straight out of a sci-fi movie.
I know, it's really cutting edge stuff.
So we've gone from like basic cables and pulleys to hydraulic systems. And now we're talking about like computers that can like think for themselves
It's been quite an evolution.
and like keep the plane flying even when things go wrong.
Exactly.
That's pretty amazing.
Yeah.
All right, well, this has been really interesting stuff, but I think we should probably take a break here.
Okay.
We'll be back in a moment to talk about some even more specialized control surfaces
Sounds good.
and configurations. Stay tuned.
All right.
We'll be right back.
See you soon.
Welcome back to our deep dive on flight controls.
It's good to be back.
So last time we were talking about all these like basic control surfaces, ailerons, elevators, rudders.
Yeah, the primary ones.
Right, and you were about to tell me about like some even more specialized ones.
Oh, yeah, there's a whole world of fascinating control surfaces out there.
Okay, well, let's hear about it.
So we were talking about ailerons last time and how they can sometimes cause this weird thing called adverse yaw.
Yeah, adverse yaw. That sounds kind of dangerous.
It's not dangerous in the sense that it's going to cause the plane to crash,
Yeah.
but it can be a bit of a nuisance for pilots,
Okay.
especially when they're trying to make precise maneuvers.
So like, what is it exactly like? What happens?
So imagine you're flying along and you want to turn to the right.
Okay.
So you use the ailerons to bank the plane to the right.
Mm.
But as you do that, the downward deflected aileron on the right wing creates more lift,
Okay.
but it also creates more drag.
Okay, so more lift is good.
More lift is good.
More drag, not so much.
More drag, not so much in this case.
Okay.
Because that extra drag on the right wing
Yeah.
actually causes the nose of the plane to yaw to the left.
Oh, wow. So it's kind of like the plane is fighting against the turn?
Yeah, that's a good way to put it.
Okay, so what do they do about that? Like, how do they fix that problem?
Well, there are a few different solutions.
Okay.
One is to use something called differential ailerons.
Differential ailerons.
Yeah.
Oh,
So
no.
with differential ailerons, the aileron that's deflecting downward to create lift actually moves down further than the aileron that's deflecting upward.
Okay, so the one that's going down moves more than the one that's going up.
Exactly.
Okay, and why is that?
Because that creates more drag on the downward moving aileron, which helps to counteract the yawing motion.
Okay, so it's like balancing out the drag.
Exactly.
Okay, that's pretty clever.
It is.
And are there other ways to fix this adverse yaw problem?
Yeah, another solution is to use something called freeze ailerons.
Freeze ailerons.
So freeze ailerons have a little hinged section at the bottom.
Okay.
That sticks out when the aileron is deflected upward.
Uh-huh.
This creates drag on the upward moving aileron, which again helps to counteract the yaw.
Okay, so both of these solutions, they're basically just like playing around with the drag
Yeah, they're manipulating the drag.
to try to keep the plane
Yeah,
flying
to
straight.
tip it balance.
Okay, that's pretty cool.
Yeah.
Okay, so what else you got for me? Like what other weird and wonderful control surfaces are out there?
Well, let's move on from ailerons and talk about some alternative designs for the horizontal control surfaces.
The horizontal control surfaces, so the ones that control pitch.
Exactly, the ones that make the plane go up and down.
Okay,
So,
great.
the usual setup is to have an elevator that's attached to a fixed horizontal stabilizer.
Right, that's like the classic tail design.
Yeah.
Oh.
But there are some other options out there.
Okay, like what?
One option is to use a stabilator.
A stabilator.
Yeah.
Okay, I've never heard of that.
So with a stabilator, the entire horizontal tail surface moves.
The whole thing moves.
The whole thing pivots
Oh, wow.
to control pitch.
Okay, so it's not just like a little flap, it's the whole tail.
The whole tail move.
Okay, that's pretty wild.
It is pretty cool.
And why would they do that? Like, what's the advantage of having a stabilator?
Well, it can be more efficient in generating lift and control, especially at higher speeds.
Okay, so it's like a more powerful elevator.
In a way, yes.
Okay, cool. And what else? What other weird horizontal control surfaces are out there?
Well, another option is to use a canard.
A canard,
Yeah.
like the duck.
Like the duck.
Okay, what does a duck have to do with airplanes?
So a canard is a small wing-like surface that's mounted in front of the main wings.
Okay, so it's like a mini wing at the front of the plane.
Yeah, exactly.
Hi.
And by controlling the lift generated by that forward surface, you can control the plane's pitch.
Oh, wow. So it's like a forward elevator.
Yeah, you could think of it that way.
Okay, and are those actually used on real planes?
Oh, yeah, definitely.
Okay.
They're not as common as the traditional tail-mounted elevators,
Okay.
but you'll find them on certain aircraft, especially those that are designed for high maneuverability.
Okay, so like fighter jets and stuff.
Yeah, fighter jets sometimes have canards.
Okay, that's pretty cool.
And you know what's even cooler?
Why?
The Wright brothers actually used a canard on their first airplane.
Really?
Yeah, the Wright Flyer had a canard.
Oh, wow. So it's like an old idea that's come back into fashion.
It's a classic design that's still relevant today.
That's amazing. Okay, so we've talked about stabilators and canards. What other funky control surfaces are out there?
Well, how about V-tails?
Details. Oh, yeah, those look so cool.
They do look cool.
Yeah, it's like they took the elevator and the rudder and kind of like mashed them together.
Yeah, that's a good way to describe it.
Okay, and so how does that work? Like, do those surfaces act as both the elevator and the rudder?
Yeah, exactly. They're called ruddervators.
Ruddervators.
Yeah, and they combine the functions of both the rudder and the elevator.
Okay, so it's like a 2-for-1 deal.
Yeah, it can save weight and reduce drag.
Okay, but I'm guessing there's got to be some downsides, right?
Well, controlling a V-tail can be a bit more complex than a traditional setup,
Okay.
and they can be more susceptible to certain types of instability.
Like what kind of instability?
Well, one example is something called Dutch roll.
Dutch roll.
Yeah.
Okay.
It's where the plane kind of rocks back and forth and yaw.
Oh, wow. That
Yeah.
sounds a little scary.
It can be a bit unnerving, but skilled pilots can manage it.
Okay, so it's not like a major safety hazard.
No, it's just something that pilots need to be aware of.
Okay, so V-tails, they look cool, but they're a little bit trickier to fly.
You could say that?
Okay, all right. Well, this has been really interesting stuff, but I think we should probably take a break here.
Okay.
When we come back, we can talk about some of the secondary flight controls.
Yeah, there's a whole bunch of other interesting systems we haven't even touched on yet.
Okay, great. Well, we'll be right back after a short break.
All right, welcome back. So last time we were talking about all these like really crazy control surfaces like canards and V-tails.
It's pretty cool designs.
Right, and you kind of left me hanging there. You were talking about like the future of flight control and like autonomous planes and stuff.
Yeah, that's a topic that always gets people thinking.
Right, like are we all going to be like riding robot planes soon or what?
Well, it's definitely a possibility, but I think it's important to remember that pilots are still essential, even with all the advances in technology. Okay, yeah, that makes sense. Like, you can't just, like, put a computer in charge of a giant metal tube full of people and just hope for the best.
Exactly. There's still a lot that computers can't do, and that's where human pilots come in.
So, like, what do pilots actually do in modern aircraft? Like, I mean, with all these fly-by-wire systems and autopilot and stuff, like, how much control do they really have?
Well, think of it this way. The pilot is like the conductor of an orchestra.
Okay.
They don't play every instrument, but they guide and coordinate all the musicians to create a harmonious performance.
Okay, I like that analogy.
So in the same way, the pilot doesn't directly control every single system on the plane,
Okay.
but they're responsible for making sure that everything works together smoothly.
Gotcha. So they're like overseeing everything and making the big decisions.
Exactly. They're monitoring all the systems, making decisions about the flight path, dealing with any unexpected situations.
So they're still very much in charge.
Absolutely.
Okay, that makes sense. But what about autopilot? Like, I mean, that can actually fly the plane, right?
Yeah, Autopilot is a really cool system that can take over some of the tasks from the pilot.
Okay.
So it can maintain altitude heading and even follow pre-programmed routes.
So it's basically like cruise control for airplanes.
Yeah, you could say that.
Okay. But I'm guessing it's not like you just flip a switch and the plane flies itself all the way to the destination.
Not quite. The pilot is still monitoring the system and can take over manual control at any time.
Okay, so it's more like an assistant than a replacement?
Exactly. It's a tool that the pilot can use to reduce their workload.
Gotcha. Okay. One thing that kind of worries me about all this technology is like, what happens if something goes wrong?
That's a very valid concern.
Like, what if a computer crashes or a sensor fails or something?
Well, that's why modern aircraft are designed with a lot of redundancy.
Redundancy.
Yeah, basically it means that there are backup systems for all the critical components.
Oh, okay. So if one thing fails, there's another one ready to take over.
Exactly. And not only that, but the systems are designed to be fault tolerant.
Fault.
Yeah, which means that they can continue operating safely even if a component malfunctions.
Oh, wow. So it's not just about having backups. It's about the systems being able to, like, work around problem.
Exactly. They use sophisticated algorithms to detect and isolate faults.
Okay, that's really impressive.
It's pretty amazing engineering.
Yeah, it's like having a co-pilot who can fix things mid-flight.
It's all about ensuring the safety of the passengers and crew.
Okay. Well, that makes me feel a lot better about flying.
Good to hear.
There's one more thing I wanted to ask you about. It was mentioned in our source, but we haven't really talked about it much, and that's stability augmentation systems.
Oh, yeah, those are pretty cool.
So, like, what are they and how do they work?
So stability augmentation systems are designed to make the plane fly more smoothly.
Okay.
They use sensors to detect any unwanted movements like turbulence or wind gusts.
Yeah.
And then they make small adjustments to the control surfaces to counteract those movements.
So it's like having an invisible hand that's constantly keeping the plane level.
Yeah, it's a good analogy.
Okay, and why is that important? Like, why do they need those systems?
Well, for one thing, it makes the flight more comfortable for the passengers.
Yeah, less turbulence is always good.
Exactly. And it also reduces the workload on the pilot.
Okay, that makes sense.
Yeah.
So we've talked about the past and the present of flight controls.
Yeah, we've covered a lot of ground.
But what about the future? Like, where do you see this technology going next?
Well, one of the most exciting areas of research is autonomous flight.
Autonomous flight, so like pilotless planes.
Exactly.
Do you think we'll see that happening anytime soon?
Well, it's hard to say for sure, but there are already a lot of companies and research institutions working on it.
Okay.
And there are definitely some potential benefits to autonomous flight.
Like what?
Well, for one thing, it could make flying more efficient.
Okay.
Autonomous planes could fly more optimal routes, saving fuel and reducing emissions.
Yeah, that makes sense. And what about, like, safety? Like, wouldn't it be safer to have a computer flying the plane?
Well, that's a complex issue. There are arguments to be made on both sides.
Yeah.
On the one hand, computers don't get tired or distracted like humans do.
Right.
But on the other hand, they can't always adapt to unexpected situations as well as humans can.
So it's a trade-off.
Yeah. There's no easy answer.
Okay. Well, I guess time will tell.
Exactly.
All right. Well, that brings us to the end of our deep dive into flight control systems.
It's been a fascinating journey.
It really has. Thanks for sharing your expertise with us.
My pleasure.
And for our listeners out there, hope you learned something new today.
Keep exploring, keep learning.
And until next time, happy flying.